Imagine a world where computers don't just calculate or process, but actually create. What if computers could learn to create on their own? Welcome to the dawn of creative machines, an era where artificial intelligence transcends traditional boundaries. Here, we explore the intriguing concept of machines as creators. This revolutionary idea is not just theoretical. It's the bedrock for generative adversarial networks, or GANs, which arm machines with the ability to not only learn but to innovate. This isn't just science fiction, it's real, thanks to generative adversarial networks. So, what exactly are generative adversarial networks, or GANs? At their core, GANs are a fascinating blend of two neural networks engaged in a clever tug-of-war. These networks are aptly named the generator and the discriminator. The generator's role is akin to that of an artist, striving to craft images or other forms of data that are indistinguishable from real-life examples. It learns to create these from random noise, essentially starting with a blank canvas each time. On the other side, we have the discriminator, acting as the art critic. Its job is to scrutinize the outputs from the generator and determine whether they're real or just well-crafted fakes. This dynamic creates a continuous loop of competition and improvement. As the generator improves its artistry, the discriminator sharpens its critical eye. The training process can be likened to a game of cat and mouse, with each side evolving to outsmart the other, pushing the boundaries of what artificial intelligence can create. With these roles defined, the next question is, how do these components interact to learn and create? First up in our GAN breakdown, the generator, the artist of the AI world. Imagine a painter, but not just any painter, one that learns from every stroke it makes, adapting and evolving with each canvas. That's the generator in the realm of generative adversarial networks. At its core, the generator's mission is to create data so convincing that it can pass off as the real thing. It starts with something akin to a blank canvas, a random noise vector. This vector is no masterpiece on its own, but it's the seed from which complexity grows. As the generator works, it's constantly critiqued by its partner, the discriminator, whose job is to judge if the output is real or fake. The generator learns from each feedback. If the discriminator isn't fooled, the generator tweaks its technique, adjusting weights and biases in its neural network. This process is iterative, a sophisticated dance between creation and criticism, all aimed at perfecting the art of imitation. While the generator crafts its art, the discriminator plays a crucial role in honing this artistry. Meet the critic in our AI art gallery, the discriminator. At its core, the discriminator's role is pivotal. Think of it as a vigilant gatekeeper that scrutinizes every piece of data it encounters. Its primary job? To distinguish genuine data from forgeries created by the generator. This is no small task. The discriminator examines each input, be it an image, a sound, or a text snippet, and makes a judgment, real or fake. This relentless analysis is crucial. Every time the generator produces a new output, the discriminator evaluates it. It learns from both the real data it knows to be authentic and the faux outputs presented by the generator. Through this process, it sharpens its ability to detect subtleties and nuances that differentiate genuine from counterfeit. Moreover, the discriminator's verdicts are not just passive judgments. They serve as direct feedback to the generator. This feedback is vital. It informs the generator about the quality of its fabrications, nudging it to refine and enhance its next creations. Together, these two neural networks push each other towards perfection. But what does this mean for the future of AI? Now that we understand the nuts and bolts of GANs, let's consider their broader impact and future potential. Generative Adversarial Networks, or GANs, have already begun to make their mark across various domains. In the realm of art, they are not just tools for creating new pieces, but are also redefining the boundaries of creativity, allowing machines to collaborate with human artists to produce work that is both unique and compelling. In medicine, GANs are used to generate synthetic data for training models where real data may be scarce or too sensitive to use, such as in personalized medicine and disease diagnosis. But the future of GANs stretches far beyond these current applications. Imagine a world where GANs assist in solving complex environmental issues by modeling and predicting climate change effects with high accuracy, or where they design entirely new materials at a molecular level that could revolutionize industries. As these networks become more sophisticated, they hold the potential to not just assist but also accelerate the pace at which machines learn and create. This could lead to more intuitive interfaces that understand and adapt to human needs in ways we are just beginning to explore. However, with great power comes great responsibility. The development of GANs raises important ethical questions. Ensuring these powerful tools are used wisely and do not perpetuate biases or facilitate deception is crucial. The path forward must include robust ethical guidelines to govern the use of this transformative technology. As GANs continue to evolve, they not only redefine the boundaries of machine creativity but also challenge us to reimagine the possibilities of AI.